Hello and welcome to the EMEA Online Virtual Summit. My name's Steve Bryan and I'm a developer advocate in our AWS Developer Relations team based out of the UK. All my details are on the slide there. Feel free to contact me and happy to receive feedback on this session or any questions that you may have. Now, this session is about scaling permissions management with attribute-based access control. Now, what does that mean? That means that we'll talk about how you can use identity and access management in AWS to scale your permissions to allow you to reach multiple users or projects or complex user scenarios in your environment without having to worry too much about hard coding parameters in there. So we use attributes or tags in AWS to do that. So let's dive into it. The first thing is I want to recap some IAM knowledge. I just want to make sure that everyone watching, we spend the first 5 or so minutes just recapping IAM, what the terminology is, so when we get to the demo and things, you can really understand what we're talking about. So what are the purpose of permissions in your organization? Well, of course, the goal of most organizations and technology teams is to enable their business to innovate, give them the agility to move fast and give builders the freedom that they need to move forward. And obviously the goal of permissions is to ensure that dangerous actions are prevented, that you're using cost-effective solutions, that you're making sure that there's an accountability security posture in your organization as well. So permissions work in a very simple way. In the simplest term, they specify who can access what. So you have resources such as EC2 instances or serverless functions or secrets in Secrets Manager or whatever they may be. And then you have permissions, and you assign roles and features of these permissions to give certain actions, allow certain actions on those resources, and then you assign those permissions to users, so users are able to perform those actions on those resources, and they have permission to do so. So very simply, identity and permissions is around specifying who can access what in your organization. Now there's 2 parts to permissions. The first part is your job, which is to define the specification, the definition of which entities are allowed to perform which actions on which specific resources in your account. And in IAM with AWS, you can also add conditions there, and that's going to be a key part of what we focus on with ABAC today. The second part is enforcement, and this is AWS's job. It's our job to ensure that the service evaluates permissions and allows or denies access. It has to decide how to move forward with that request. So when you define access policies, you specify which IAM principles. So these are the principle is the thing that's making this request. Are allowed to perform which actions on specific resources, and then IAM enforces this by evaluating the request and what's defined in the policies and giving you a yes or a no, an allow or deny. So let's look at the IAM policy structure and what it looks like. It's made up of some key elements that we just want you to make sure you understand as we dive deeper into ABAC. The first thing is the principal. This is the entity that's allowed or denied access. This is a user or a role typically. The second thing is an action. What is the type of action that is allowed or denied? What access do you want that user to have? Do you want them to be able to get an object from S3, for example? The third thing is on what resource are they able to take that action? So in this sense, in this example, we are defining a specific SQS queue, for example. That could be an S3 bucket or an EC2 instance. And you know that you can use wildcards here to allow actions on all EC2 resources, for example. And then the final part of the IAM policy is the condition. Now the condition is under what conditions is the access defined as valid. So you can use these tag-based conditions. Is the tag that is specified when that request is made, is it equal to a specific value? For example, in this case, is the project tag access to the value or the string of pickles? So these are the key parts of an IAM policy. We've got the principal, the person who can or role that can take that action, the action that they're actually allowed to take, the resource on which they're allowed to take that action, and then the conditions under which we would allow or deny that specific statement to pass in the policy evaluation. So if we look at policy enforcement and policy evaluation, the first thing is we always start our decisions at a deny. And then we evaluate all applicable policies, and we look, is there an explicit deny? And if there's an explicit deny, the decision is deny. If there's not, we say, is there an allow? And if there's an allow for a specific action, the decision is an allow. And if there's not an allow or a deny, again, the default deny takes place. The decision is to deny by default. So we look at permissions and the way that this is implemented in most organizations. We typically implement something called RBAC, or role-based access control. And role-based access control is very popular. You would assign some permissions and you would assign them to users or groups of users, and you would group your users into specific groups that have specific permissions associated with them and allow them to access resources. Now, there's many benefits of role-based access control in AWS. One of them is that you're able to grant users specific permissions, and you can assign a collection of roles to a group, or permissions to a group. You can create distinct roles for each unique permission, so you can be very granular and very specific around what you put in those policies as well. And it's a very well practiced process in AWS. It's super popular. It's how most people are using AWS to do permissions today. But what we want to spend the remainder of this session talking about is something called ABAC, or as we'd like to call it, attribute-based access control. So what this is using attributes to create general permission rules that scale with your organization. What that means is we take attributes. So an attribute is a key or a key value pair, and they're predefined by a provider, or they're custom. And in AWS land, you can think of a attribute as a tag, a key value pair. We can tag our resources in AWS, and we can tag our IAM policies in AWS. We can tag our roles. We can tag our users, for example. And these tags are basically attributes, a key or a value. In this example, I have a user here, and they have multiple tags. They have an ID, in this case Dave. We have a project, in this case green, and we have a team that this person works on as well. This person works on the platform team. But then we can also assign tags to our resources as well, and attributes to our resources. In this case, an EC2 instance is the project tag of green, an environment of development, and created by Dave. So it's actually created by that user. So we're actually tracking that as well in this use case. So attributes become quite powerful in AWS, and traditionally they've been used for things like auditing or cost control, or identifying ownership of resources. But actually using attributes or tags in AWS for access control is a really great way to scale your permissions management, and that's what we'll be spending the rest of the session talking about today. So when we think about attributes and we think about tags, let's take the project tag, for example, that we saw on the previous slide. We have multiple users now, red, green, and blue project users, and then we have multiple resources on the other side. Now these resources have, red. Some of them are red, some of them are blue, some of them are green. But no, we don't have lots of policies here. We don't tag. We're not assigning roles to all these different users. We're not assigning permissions specifically to groups that these users are in. We're defining an IAM role that has specific permissions, and in those permissions, it's a kind of set and forget approach. And you'll see this when we get to the demo, that we're able to define these permissions once based on a dynamic condition that says that if the principal tag is red, they can start or stop an instance with the tag that's red, for example. But we never actually define the word red in that policy whatsoever. In fact, that same policy would apply to if a user is blue, they can access resources that are blue. And then if you create a new project for your purple project, for example, you could also just use that same policy, and your users would automatically be able to access and create those resources with those tags. So you can imagine there's lots of benefits here to attribute-based access control. You can scale with innovation. The developers can build, the policies scale. You can add new projects without much risk. The permissions automatically apply based on attributes. So if you set a permission to start or stop EC2 instances with a tag that's the same as the user's tag, then this just scales. You add more EC2 instances, as long as they're tagged appropriately, that user then has permission to start or stop those instances. Likewise, if you add new users, they can automatically have permissions to access those resources as well. Granular permissions are possible without requiring updates, and you can audit frequently and stuff. There's lots of power in doing attribute-based access control. So what are some examples of attribute-based permissions? Well, we can grant developers read and write access to their project resources. We spoke about that already. We have multiple colored projects, red, green, blue. We can grant developers read or write access to their projects. That's pretty straightforward implementation, and what we'll show you in the demo as well. But we can also do something called tag on create, or force tag on create. And what that means is that we can force developers to assign tags to their resources before they're allowed to create them. So we can kind of enforce this in our IAM policies. We can say that if Dave, who's let's say is in the red project, he can only launch an EC2 instance if he tags it with project red. So that allows accountability of ownership and allocations for a project, and stops users being able to do sprawl without tagging their resources as well. And it also means that I can still manage only the resources that I own, or that I have the required access tags to do so. One of the other features of ABAC in AWS Identity and Access Management is a feature called session tags. Now, this is something we launched last year at reInvent, and it's actually really powerful. Now, traditionally with ABAC in AWS, you would take multiple roles, let's say the red project role and the blue project role, and then you would tag your users, and you would allow users that had the same project tag to assume that role. Now that works for IAM users. With session tags, you're actually able to pass session tags when you use the assume role API in IAM. So as my user assumes that role, I would pass the red tag with that user. Now you can do that in IAM, and we'll show you that in the demo shortly. But where this becomes really powerful is when you can do it with third-party identity providers, and you see some like Ping and Okta and Auth0 and a few others here on the screen. This is super powerful because now what I can do in my identity provider, let's take Ping as an example, I can provide an attribute of project to that user, and then I can say on my IAM role that when my SAML federated user assumes this role, they have to pass a session tag of project. And then when they're in that assumed role state and they're actioning their resources in that with that assumed role as their principal, this dynamic tag is allocated to that role, which is passed through as a session tag. If I was to change that user to project green, for example, they would then, on their next session, they would have a new session tag. They'd now be in project green, but I'm managing those tags in my identity provider. So this is a really powerful way to actually pass session tags through. And what this eliminates is what I described about having a role that says blue project team or red project team roles. You can just have a single role and take those, allow users to assume that role as long as they pass a project tag when they assume that role. So they can actually, it makes it even simpler in terms of set and forget. You're only setting that one role for all potential projects in this example. So when we look at applying ABAC in your organization, there's a few steps that need to take place. So we'll just walk through them now. The first thing you need to do is you need to have identities with attributes or ones that are federated to AWS with attributes through session tags. You need to configure your tagging controls. This is tag on create and who can delete and update tags. That's super important. And then you have to require attributes for new resources. This is the tag on create part, number 3 here. New resources have to have these attributes, and then we set the permissions based on those attributes. So we set the permissions saying you can only do this action if you have the attribute that matches that resource's attribute. So we're doing this kind of string comparison on the tag values when we look at the policies, and you'll see the policies in the demo shortly. Then we can go ahead, we can create new resources, we can create new users, and our permissions automatically apply. So I know it's a lot to take in and much harder to describe without the policies in front of me. So we'll dive into the demo now, and we'll just talk through the demo, then we'll get straight into the console and show you what we're going to be demonstrating today. So we're going to demonstrate a simple implementation of ABAC using IAM. So in this case, and we spoke about the session tags feature in the earlier slides. So the first thing we're going to do is we're going to take our blue user here, and they're going to assume a role. And when they assume that role, they're going to use this attribute, this API called tag session, and this is part of the assume role STS API. So when this user assumes this role, they're going to pass a session tag with them. From this tag's called access project, and they're going to pass the value of blue. So now I'm operating in the scope of this IAM role. This IAM role is now my principal. I'm in the AWS account and I'm operating in that space. And what we're going to do is we're going to start and stop some EC2 instances. And what should happen is that I'm not able to start or stop instances that have a red tag because I'm tagged as blue, but I am able to start or stop EC2 instances that have a blue tag because that matches my tag value as well. And then the second part of the demo, we're going to have our red user. They're also going to assume the role and pass a tag with a session tag with them of red, access project red. And then that user is going to, we're going to force tag on create. So that user is going to try and create an EC2 instance with a blue tag, and that should hopefully not be successful. And then they're going to create a EC2 instance with a red tag, and that should be successful because they're in the same they have the same tag value, so that string comparison will be correct. So we'll dive into the console now, and we'll show you the demo, and we'll get hands-on with this stuff, and then we'll come back and summarize. So we're here in the AWS Management Console, and we're in the Identity and Access Management users view here, and you can see that we have 2 users in our account. Now, for the sake of this demo, I'm going to be using Identity and Access Management users. So I'll be using these 2 users that you see on the screen here. But at this point, I just want to take the time to highlight that most of you will either be using this approach or you'll be using a third-party identity provider, someone like Ping or Okta. And that works in a very similar way to what we're talking about now. So the same principles in terms of assuming the role and passing the session tags, which we'll dive into, applies both for IAM users and for users that are residing in third-party identity providers. So you do assume role with SAML instead of assume role API call. So we have these users, and these users need to have permission to assume role. So we've put them in this group called ABAC users, and they have a very simple permission here. The first thing is they can assume the role. So that's pretty simple. We give them the permission to the STS assume role on the resource of the project team's role, which we'll show you shortly. But the most important thing here is that we have this permission to tag the session. This gives our users permission to pass session tags with their assume role API call and tag that session. Now, if we look at our role, we have a trust relationship on the role here, and the trust relationship is basically saying the same thing, that our users in this account, in this case, so we're all in the same account, although this could be cross account, are allowed to assume the role and tag the session. The main difference here is that we see a condition that says that they must provide a request tag. So this request must have a tag associated with the request, the assume role request, with a key of access project, and in this case they can provide any project name, so red, green, blue, whatever they decide to call their project. So these users can assume the role and pass this session tag. Now if we go back to our role, we can see that our role doesn't have any tags associated with it, and this is where the session tags feature becomes really powerful. This is an agnostic role, it's a dynamic role, it's not a blue project team role or a red project team role. It's a specific role that says that people are allowed to perform certain actions based on the policies that we have attached to it. But there's no tags here. But when our users assume this role and pass these session tags, that is when this role then in that assumed state has these tags associated with it. So it kind of dynamically assigns these tags based on the session and the user that has triggered that session. And services like Ping and Okta and many other third-party IDB providers that you saw on the slide earlier are able to pass these, use this session tags feature to pass tags when they're assuming a role in your AWS account. So let's just take a look at some code and how we would pass the session tags when we're assuming role. So we have 2 scripts here. One is a assume role blue, and the other one is assume role red. Now these are very similar scripts. What they do is they use the STS assume role API. They pass the yarn of the role they want to assume. We have a name, so in the blue script we have blue session, and then we pass tags. This is the most important part from an ABAC perspective. We pass this access project tag of blue. So we should meet our condition when we assume this role that we're passing the access project tag. And for the blue user, we're passing blue. And for the red user, we're passing red. And we call this a red session. The only other difference here is that I'm assuming the role using different CLI profiles here on my local machine. So one has the keys for the red user 2 red, and one has the keys for user 1 blue. So let's go ahead and run these scripts. The other thing the script does is it once it's assumed the role, it gives me a console URI that I can then load the console and log in as that assumed user. So just a few some URL manipulation going on down here. This script's available in the IAM docs. It's not something I authored myself. So we're over here in the terminal. We're going to run this script. We're going to run blue, Python assume role blue. And you can see that we get a URI here. And over here in our Chrome incognito tag, this is where we're going to be our blue user. And you can see this is our blue user because in the script we called that session name was blue session. You can see that up here in the console. Now if we go back, we're going to run the red script. We're going to get a link for our red user. And we'll head over to Firefox over here, where we will be, in Firefox will be our red user. We will have our red session. So in this browser in Firefox, we have assumed the role of project team's role, and we have a access project tag that we've passed with the session of red. And in our incognito tab here in Chrome, we have the tag of blue. So if we head back over to the management console and we look at some of the permissions that we've created to associate with this role. The first one I want to look at is this policy called access same project team. This policy allows us to, very simple policy, allows us to start and stop EC2 instances, but again with a condition that the tag on these EC2 instances must match the tag on the principal, in this case the role that you've assumed. So the session tag that we pass through of access project must be the same as the access project tag on the resource. This is a resource tag, not a request tag, which we saw in the trust policy earlier. This is a resource tag, so the tag of the resource must match the tag of the principal, which is making that request. And then beyond that, we just have some describe operations here allowed, and this just allows us to see stuff in the console, so you can see a nice view of what we're doing here when we try and start and stop instances. So if we head back over to our blue user and we go to the EC2 console, you'll see that in Virginia here we have one instance running. We actually have a few instances here. We have one here called the red team only, and this instance is tagged with access project red. And we have another one here called blue team only, which is tagged with access project blue. So we're here in our blue session, as you can see up here. So I'm going to try and start this red instance, this red tagged instance. And what do we expect would happen? We get a deny. The condition is not met that the tags match. So let's cancel that operation and try and start our blue team instance. And you can see that we're successfully able to start that instance because the tags are identical. The tag on my principal, the role that I've assumed, passed through as my session tag, is identical to this tag that you see here on the screen, this access project tag with a value of blue. So that condition is met and we're able to start our EC2 instance. Great. So we head back over to IAM here. We have another policy on our role, and this one's called only create with tags. Now this is an important policy. This basically forces us to tag on create. So we see a very simple statement here that says that we can create volumes and run instances. These are the APIs required to run a new EC2 instance, as well as create tags. However, when we create tags on an instance or a volume, which are the two things that are tagged when you create an EC2 instance, we have this condition that the request tag, again, we're looking at request tag here, not a resource tag, the request tag, so the tag, the access project tag that's passed in the request matches the access project tag value of the principal, the role that we've assumed. And then we have a context key here called EC2 create action that this is on the run instances API. So when we're creating tags on the run instances API, this access project tag must be in the request and it must equal the same as the one associated with the principal making that request. So let's head over here to our red user and we're going to go into our EC2 console and we're going to see if we can force tag on create. So we're going to go and launch a new instance. And so we're going to launch an instance with the Amazon Linux AMI. We won't worry too much about the details here. We're mostly interested in the tags. So we'll add a tag, our access project tag, and we'll call this green. So our red user here in our red session is going to try and create a instance with the tag of green. We will have no security group, and we could just check in our config here in our kind of summary that we're trying to launch with access project green. Go ahead and launch this instance. We'll go without a key pair. Launch the instance, and we get an error. As expected, I'm the red user. I shouldn't be able to launch an instance with a tag of green, should I? So back to the review screen here, we can edit the tags. We can change this to red. We go back to review and launch, and then we also, again, proceed without a key pair, and you can see that we are able to launch that instance. We're able to successfully launch an EC2 instance because it is tagged with the access project of red. So we are forcing tag on create. We are forcing our user to have to tag resources when they create those resources. So a pretty straightforward and basic example, I think, of how you can use ABAC in your account, and hopefully gave you some insight into how you can use condition keys, conditions and context keys such as a request tag and a resource tag to ensure that you can force tag on create, as well as ensure that you can only allow users to perform actions when they need to. Now, I think the main benefit here that I see is that this is very much a set and forget policy. These policies at no time included the words red or blue. I could actually move a user from the red project to the blue project, and when they start a new session, their new session tags would propagate, and they would be able to access and operate on the resources in their new project versus their old project, for example. So this is very much a scalable way to think about permissions management, and setting these things once and then allowing, based on attributes, for you to be able to assign permissions and actions on specific resources in your AWS environment. So we'll head back to the slides now to wrap it all up. So what did we do in the demo there? Well, what we did was, first of all, we had this role trust policy in our role, and we firstly said that our users were able to assume the role, but only if they passed, they're allowed to assume the role, but they're also allowed to tag the session as well. This is an important permission when you're doing the session tags feature of ABAC in AWS. But then finally we had this condition that said that if you do this assume role operation, you must pass a session tag of access project when you do so. So this allowed us to assume that role and operate it as someone that was a principal that was tagged as blue or red. Then we had a policy that allowed us to stop or start instances. A very simple policy with a condition that says only allowed to do this if the EC2 resource tag is the same as the principal's access project tag as well. And then finally, we did a force tag on create. We said that you can create new EC2 instances, but this condition at the bottom says only if the access project tag matches the principal. And the key thing here is this is a request tag, not a resource tag. We're actually, in this condition, we're evaluating if the request tag is the same. So hopefully that gives you some insight. The slides will be available, so you'll be able to see these policies and take a look at them yourself and see how you can use them as examples to apply them to your organization. So before we wrap up, I just want to highlight some final ABAC best practices to keep with you before we wrap up the session. The 5 best practices I want you to take away are: the first one is that you should reserve a subset of attributes or tags for access control. Some resources, there's a limit on the amount of tags you can tag resources with, so make sure that you kind of allocate 1 or 2 for access permissions, whether that's a project or a team or whatever it may be, whatever works for your organization. Make sure that only approved entities can set or modify tags. So that's something we didn't actually cover in the demo, but a good best practice, and there's some great documentation on this, is making sure that you can only edit or update tags if you're approved to do so, and if the value of those tags is the same as your principal again. The third one is to tag everything during creation. So this is the force tag on create. Everything gets tagged, so permissions apply immediately. There's no manual going back and trying to check, did I tag this? Didn't I tag this? Oh, now I don't have permissions to tag this because I didn't tag it in the first place. I need to go and speak to my security operations team. So make sure that everything's tagged on creation. Rely on attributes to grant permissions to access resources. Try not to go around the process. And obviously, of course, you should always periodically audit to ensure that the resources are tagged appropriately, that your permissions have least privilege in your account as well, which is a best practice that we always recommend on your identity and access management policies, to make sure you're always enforcing least privilege in your AWS account. So that's an overview of ABAC in AWS, and hopefully we gave you a great example. As always, my details are on the slide there. You can reach out to me on Twitter, and I hope you enjoy the rest of the conference. Thank you very much.